Hello, students. Today we're going to be doing slope-intercept form, very important form of the equation to make lines. All right, so I'm sharing my screen now. This is 5.3 part 1, slope-intercept form, page 329. Now, I know for today you only have 5.3 and 5.4. However, both lessons are 2 parts, so it actually is going to be quite a bit. So I'm going to be making 4 videos, maybe 3. I'll look at lesson 5.4 to see if I can condense both parts into one video. Either way, so let's go ahead and learn. The slope-intercept form is the simplest form of a linear equation to use for graphing. Now you might be like, well, Mr. Brown, you didn't tell me what a linear equation is. So let's go over some vocabulary, and this will help to ease your tensions here. So the first vocabulary word is a parent function. What is a parent function? It's the simplest function in a group of functions. Now, honestly, just knowing that is probably about as far as you're going to need to go. Basically, the idea is equations can start getting very complicated when you start adding lots of numbers and fractions and things to them. So think of any group of equations that's the simplest one. So then there's the linear parent function, which is this, y equals x. So basically, if you're trying to make a graph, that's probably going to be like the simplest one. If x is 1, then y is 1. If x is 2, then y is 2. So your points are going to be 1, 1, 2, 2, 3, 3, 4, 4, and so on. So the idea is the parent function is just a very, very simple equation, okay? Now, a linear equation is any equation that graphs as a line, okay? So I'm just going to draw just a really quick graph here. If you have a linear equation, the shape of your graph is going to be a line. Simple as that. Doesn't matter where the line goes, it's going to be a line. Now, some lines are vertical, and those are not really considered a function, so they're kind of a different category if the line just goes straight up and down. But the idea is that any other line that's not straight up and down is considered to have been created from a linear equation. A nonlinear equation is an equation that graphs as another shape. Now, when you get to algebra C and D, you'll be graphing some nonlinear equations, but the most common nonlinear shape is called a parabola, and it's the shape of a U. Okay, but don't worry about that for now. You just need to know linear equation makes a line, nonlinear makes another shape. Now, in this case, a parabola is a specific type of equation that makes a shape that you will learn about in the future. So this is just a preview. Okay. Now, let's learn some other things. The y-intercept is the point where your graph crosses the y-axis of the coordinate plane. Now, this little tiny graph I just made right here, the y-intercept is the point where my graph actually crosses. So see, I made a little point there right where it crosses the y-axis. And as you can see, if you have a vertical line, it's never going to cross the y-axis because it's parallel to it. Okay, so the y-intercept is the point where your graph crosses the y-axis of the coordinate plane. The slope-intercept form is a form of a linear equation that is very easy to use, and it is y equals mx plus b. So be thinking about that for a second. I want to jump over here to the side, and before I go into more detail on slope-intercept form. You may have remembered in the last video I told you that I want you to memorize some forms. Okay, so here's the first 4 forms I want you to memorize. The slope formula, y2 minus y1 divided by x2 minus x1. Of course, you solve in the top and the bottom first, and then you can divide or write it as a fraction. Number 2, direct variation. That was the last lesson I taught you, which is y equals kx. I believe I said that this is a fairly easy lesson, and it's a fairly easy equation to use. In today's lesson, I just taught you the linear parent form, which is y is equal to x, but you can also write it in function form, which is f of x, or function of x, is equal to x. Okay, so these are just two ways of writing the same form. I just want to remind you that f of x is going to become a more common form in the next few parts of algebra, okay? And then what I'm teaching you today, today's main lesson, is y is equal to mx plus b, okay? Now, let's just go into y equals mx plus b, and let me just move my camera here so you can see this. Okay, so y is the y coordinate. Now, when you have an ordered pair, as you know, you have an x coordinate and a y coordinate, okay? So your y coordinate could be like, let's say 5, and your x coordinate could be 3. I'm just picking example numbers. So your y coordinate would equal 5 if this was the point on the particular line. Now m, remember I told you in the last lesson, m, or 2 lessons ago, is the nickname for slope, okay? So we call it m when it's in the slope-intercept form. Sometimes you may call it other things, like technically, if you put it into direct variation, it would be k. But I don't want to confuse you and talk about what you call it in different forms. In the slope-intercept form, it is called m, and m is the number that is the coefficient of x, or the number that is multiplied to x, like 2x, 3x, 4x, 5x. If there's nothing written in front of it, then m would be 1. So your slope would be 1, because it would be 1 times x. And plus b. Oh, I forgot. X is your x coordinate. So in this case, it would be 3 if this was a point on the line. 3, 5. Then x would be 3 and y would be 5. And the y-intercept, as we learned here earlier, is the point where your graph crosses the y-axis, okay? Now, if you have an equation written in this form, y equals mx plus b, then, for one thing, whatever the slope is, you just read it, okay? So you're like, the number in front of x, that's my slope. So if you're asked the question, what's the slope? And you have an equation written out, then you can be like, oh, the slope is whatever that number is. And then you ask, what is the y-intercept? Or what is the point where your graph crosses the y-axis? Well, the number is just given to you. It's the value that is in this position, b, okay? So I want to talk for just a second about what are the ingredients of a graph, because this is the point where we start really doing some graphing, okay? Here's what you need to make a graph. Number 1, you need a coordinate plane, okay? And a coordinate plane is quite simply 2 lines, an x-axis and a y-axis. Second thing you need is an equation, right? So I'm just going to use this. Y is equal to 3x plus 1. Okay? So I have a coordinate plane. I just made one. I have an equation. I just made one. Now, I'm not asking you to get super comfortable where you're like, oh, just make up an equation. But I put it in the same form. Y is y. M, the slope is x. M, the slope is 3. X is your x coordinate. B is your y-intercept. And in this case, the y-intercept is 1. Okay? So I have a coordinate plane and equation. Now I need some independent variables. The independent one is, yes, Nico, that's right, it's x. Okay? So then I need, number 4 is a table of values. So I have some room over here. I'll go ahead and I'll make a little table. Now, if you don't know what numbers to put for x, put the convenient numbers I told you about. -2, -1, 0, 1, and 2. Now, I always like to make it clear and make the point of this. You can put any values you want for your x value, but you should probably put convenient values to use because you want to make it easy to graph. So these numbers are all pretty low, so they're all pretty close to the origin point on your graph here, so they should be fairly easy to graph. Okay, so my independent variables are my x values. Where do they come from? I just made them up. Why do I make these ones up? Well, these ones are close to 0, and the graph starts at 0, 0, which is the midpoint of it, so therefore they should be easy to graph. There's no rocket science behind this, okay? So now I have well, I don't have a table of values yet, but I have to use my equation, because remember, my equation serves as the rule in order to get my dependent variables, or my y values. And then I will have ordered pairs. So let's use -2. If I use -2, I'm going to use a pencil so I can erase this. If I use -2 as my value for x, then I go -2 times 3 is -6. -6 plus 1 would be -5. So if x is -2, then y is -5. If x is 1, 1 times 3 is 3. Oh, sorry, -1. That would be -3 plus 1 would be -2. If x is 0, 0 times 3 is 0. 0 plus 1 is 1. If x is 1, 1 times 3 is 3, plus 1 is 4. And if x is 2, 2 times 3 is 6, plus 1 is 7. Okay, so now I've got some points. So let's look. Do we have everything we need? A coordinate plane? I have a coordinate plane. An equation? I have an equation. Independent variables? I have those. Table of values? I have the table of values, which makes ordered pairs. So I have -2, -5. Oh, wait, just a second. Go back to my equation. It says y is equal to 3x plus 1. So that means that 1 is my y-intercept. So start at 0 and go up to 1, and I can already make a point because 1 is my y-intercept. My equation tells me what my y-intercept is. Remember, the value b is the y-intercept. So the value that is plus or minus 3x, we can also think of minus as plus a negative. So to keep it within the form, you can think of it as plus a negative. But I can automatically put that there. But wait a second, well, what's its x value? Now, if I'm on the x-axis, if I go up, then the numbers start as 1, 2. And if I go down from here, some numbers are -1, -2. So if I stay here, my x value is 0. So 0, +1. Well, hey, look on our table. We already have that point, 0, +1. Okay? So in your equation, if you are given an equation that has y is equal to something which is the slope, x plus 1, then it makes it easy. Now, let's find the slope. Well, the slope is 3. It's a whole number. Now remember, any whole number can be written as a fraction over 1. So we determined that slope in a couple lessons ago was rise over run. So that means I go up 3 because I have my slope is 3 over 1. So go 1, 2, 3, and I go over 1. Because remember we said 3 over, or 3 up, and then 1 over. So there's already a point. Well, what point is this? This is, let's see, 1, 4. Well, guess what? Look, 1, 4 is also a number on our table here. Okay? Now, since I have the table of values, I'm just going to go ahead and plot some other points. -1, -2. Let's try that. -1, so go 1 to the left. -2, go 2 down. Look what? Look, it's on the same line. Okay, and then -2, 5. So go 2 over, 1, 2, and 5 down. 1, 2, 3, 4, 5. Yep, it's also on the same line. Let's just check our slope here. Oops, I think I missed that one up a little bit too far over. So our slope was 3 over, or no, 3 up. 1, 2, 3 over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. Yep, it matches. Now I would put 2, 7, but as you can see, my coordinate plane's kind of small. I got 2 here and then 7 up. It's going to be kind of high and sort of off the coordinate plane there. So I'm just going to recommend for this lesson, I don't want to make the video too long, but I'm going to go ahead and throw the book on to the screen here. I really want to recommend that you go through problems 1 through 5 in the textbook. I know this, you may be like, Mr. Goward, how cheap, why don't you just show it to us? I don't want to make a 30-minute video here when a lot of this is stuff that you can actually look at. I'm sorry, problems 1 through 4. I'll just kind of quickly go over them. In problem 1, it tells you how to identify the slope and the y-intercept when you already have the equation written. So in this one, y is equal to 5x minus 2. So the slope would be 5 because that's the coefficient of x. And the y-intercept would be -2. So you can write your equation as y is equal to 5x plus -2, or you can just say y is equal to 5x minus 2. Okay? So it automatically gives you those values because they're written into the equation. Well, what if the equation is not written? How would you do it? So in problem 2, it says writing an equation in slope-intercept form. So let's say this is what you know about the line. This is the given information. You know that the slope is -4/5 and that the y-intercept is 7. So then you write the slope-intercept form, y is equal to mx plus b, and then you substitute in the values. -4/5 substitutes for m, because m is the slope, and +7 substitutes in for b. So now you just write it as the equation. Y is equal to -4/5 x plus 7. Just a little note, now that we're dealing with slope, slope is very often a fraction, okay? So it's always written as a fraction, even like before when I wrote it as 3 over 1, so that you can, remember 3 up and 1 over type of a thing. But just trying to make the point, though, a lot of times it's going to be a fraction, so don't be frustrated with that, okay? So problem 3 says writing an equation from a graph. Now, as you can see here, you have a graph. Now remember, if we use the form y equals mx plus b, the slope is super easy to find. Just find any 2 points on the graph, and then count from there to the point, okay? Now, well, in this one you have 4 different equations, all written in slope-intercept form, okay? So the first thing we might want to look at is, well, what's our y-intercept? Our y-intercept is -2. So automatically, I know that a and b cannot be it, because the slope-intercept in those 2 forms is +1. Okay, so I know it has to be either C or D. Okay, now without looking ahead to see what the answer is, um, we can continue with the process. Okay, so if I look at my line here, it's actually a very steep line. So remember, rise over run. So what does it take to go to the next one? So the next point, I should say. So looking at the equation, if I go up 1 and then 2 and then go over 1, then I can clearly see that my value, I'm going to erase this in just a second, for the slope would be 2 over 1 because I go up 2 and over 1. So the slope is 2 over 1, which is written as 2. So I have the slope here is either 1/2 x or 2x. Well, I just figured out from looking at the graph that my slope is 2, so it has to be d. And if you look down, you'll see d is the correct answer. Now, I just want to go over problem 4. I said I wasn't going to, but here, look, I'm going over them with you. But you can go over them more in depth if you take time to look at them yourself. Problem 4 is writing an equation from 2 points. So I have 2 points here, 0.21 and 5, -8. Okay. Now, to do that, I can use the point slope form. -8 minus 1 is -9. And then 5 minus 2 is 3. So I have -9 over 3, which simplifies to -3. Okay, so now I know what my slope is. So I can use y is equal to mx plus b, and I can literally plug in -3 because I just figured that out. Now, since I know that these points go into a line, I can take one of the points, in this case 2, 1, and I can substitute in 2 for x and 1 for y. So I have 1 is equal to -3 times 2 plus b. Okay. Now, -3 plus 2 is -6. If I isolate b by adding -6 to both sides, on this side it'll cancel, on that side it'll add 6 to 1, which gives me 7. So I can get the value for b. The y-intercept b is actually 7. Okay, so I can rewrite the equation as y is equal to -3, which I found using the slope formula, and then plus 7, which I found by substituting in one of the points that I had. Okay, I hope that helps make it clear. I hope you enjoyed the video. Thank you much.